Okay, for today we're going to talk about adding and subtracting radicals. So here's some properties, new properties today, for you to copy down. The big thing here is if we notice that we have a number out front, and B, a number out front. So we're adding the numbers out front, and it still times the same radical, same index, same radicand. So that's the important thing. They must have the same index. They must have the same. If there is not the same index and not the same radicand, then this will not work. So for example, if I have 3 index or square root of 5x minus 2 square root of 5x, then I would just add these like the square root of 5x were variables. And I would say 3 minus 2 square root of 5x. 3 minus 2 is 1, so this is just going to be 1 square root of 5x. Done. Now a couple of things that you'll run into, a couple of issues. The first issue is this, 6x squared square root of 7 plus 4x square root of 5. Now note, my radicands are different, but my indexes are the same. There are two issues with this problem. The radicands are different, automatically I can't do it. And the variables out front are different. They're not like terms, so automatically I cannot add these. So there's nothing to be done with this problem. Nothing at all, okay? So this cannot be simplified. It's already simplified. Another example like that is this one. So let's say I have the cube root of 7xy minus 8 times the fifth root of 7xy. So my radicands are the same, but my indexes are different. And because my indexes are different, these cannot be simplified. So cannot be simplified. And there's nothing that you can do. You literally stop. So just make sure that you're really paying attention to this, because there's some problems that you'll run into that are really, really easy. And you might simplify them not needing to. So let's look at another one. Square root of 12 plus the square root of 75 minus the square root of 3. This looks like the radicands can't be combined, but remember, we can simplify first. So you can simplify first. And if we simplify these first, then we might be able to combine them later. So let's simplify 12 by looking at its prime factors, 2 and 6, and 2 and 3. 2 times 3. I'm going to take out 1, 2, and leave underneath the radical 3. Let's do the same thing with 75, which is 5 and 15. 5 as 3 and 5, 15 is 3 and 5. And this would give me 3 times 5 times 5. I would circle the two pairs of 5s. So this is plus 5 square root of 3. A plus because the plus is on the outside here. And then this doesn't need to be simplified. It's already simplified, so minus the square root of 3. Now, here's the thing. Once again, we're at this point, and we have the same radicand and the same indexes for all of them, so this can be combined. So now all you're going to do is combine the numbers out front. Combine 2, 5, and negative 1 here. Okay, so 2 plus 5 is 7. 7 minus 1 is 6. So this is 6 square root of 3. And that's my final answer. Okay, let's look at another one. Okay, I'm going to give you a chance to do this on your own first, okay? And then I am going to put up the answers really quickly. So simplify these first, and then I will have the answers and we'll put them up together. So pause and simplify. Okay, you should be done with your simplifying. So my answer for the first one is 5 cube root of 2. For the second one is 3 cube root of 2. And the third one is 2 cube root of 2. They all simplified, and now we can combine the numbers out front. 5 plus 3 is 8. 8 minus 2 is 6 cube root of 2. Now, the only other thing that I wanted to talk about is multiplying, more multiplying problems. So we're kind of adding and subtracting, but what happens if we have something like this? So 4 plus 2 square root of 2 times 5 plus 4 square root of 2. Now, if I have two things multiplied together, this is going to be part of your classwork today. This is kind of like a little added bonus for you. We are going to multiply these by foiling. So that means that 4 gets multiplied to 5. 4 times 5 is 20. Then I have 4 multiplied to 4 square root of 2. Well, the 4's on the outside get multiplied. So that would be 16 square root of 2. Then we're going to move on to 2 square root of 2, multiply it to 5. So the 2's on the outside get multiplied, so that's 10 square root of 2. And then the 2's and the 4 gets multiplied, and the 2 and the 2 get multiplied here. So this would be 2 times 4, which is 8, square root of, in this case, 4. Now one of these can be simplified. The square root of 4, remember the square root of 4 is 2, so this is technically 8 times 2. Okay, so if I'm simplifying this, I have 20, plus I can add these together because these are like terms, 26 square root of 2 plus 16. And then if you're looking at this saying, well, you could do more, you would be correct. 16 and 20 can be added together because those are like terms. And that would give me 36 plus 26 square root of 2. So just in case you're given a problem where they want you to multiply and distribute, that's what you're going to do. Let's look at one more like that so that you have another example to go off of. Now these are actually, it's a special case. This is called the conjugates. Conjugate literally means that they're the same exact like binomial, but they have one is positive, one is negative. And we actually have seen this in our difference of squares factoring problem. So the conjugates would be like if I have a plus b and a minus b. So you have to have one that is positive and one that is negative for it to work. This actually distributes to a squared minus b squared. So now, if you distribute, and you can distribute it this way, you can do it like this, or you can just distribute like you would the problem before, but 5 times 5 is 25, 5 times 7 is going to be positive 5 square root of 7. Can't multiply underneath, they're not both under a square root. Negative 5 square root of 7 times 5 is negative 5 square root of 7. And negative square root of 7 times the square root of 7 is going to be negative 7. That's because it would be square root of 49. And remember, that would cancel out and just give me 7. Now, if you're looking at this, you should see that these cancel. And I have 25 minus 7. 25 minus 7 is 18. And that would be my final answer here. So conjugates, you could have also just said that this is 5 squared. Minus 7, the square root of 7 squared. That's another way to kind of have looked at this because of the conjugates rule would be to look at 5 squared minus the square root of 7 squared. Square root of 7 squared is 7. 5 squared is 25. 25 minus 7 is 18. So there's two ways to look at that kind of problem, but you can look at it with the conjugates rule, which is a plus b times a minus b is equal to a squared minus b squared. It's that difference of squares formula worked backwards. or you can just distribute, either one. All right, that is all for today. Have a wonderful day, everyone.